Have you ever glanced at a clock and felt that time itself was slipping away from you as if each second was stretching and compressing in ways you could not understand? What if I told you that your very perception of time might not be universal, and that the person sitting next to you could be experiencing the flow of moments in a way radically different from your own? The phenomenon we are about to explore is called time dilation, and it challenges every assumption we have about the linear progression of seconds, minutes, and hours. What we have long taken for granted as a shared experience of time may in fact be deeply personal and variable beyond anything our minds can intuitively grasp. Imagine for a moment that the very fabric of time itself is elastic, capable of stretching and contracting in response to speed, gravity, and perhaps even consciousness. This is not science fiction, but a real consequence of Einstein's groundbreaking theories of relativity and decades of experimental confirmation from scientists around the world. The ordinary tick of a clock on your wall could be measuring a reality that is only partially aligned with the reality of someone else observing the same clock in a slightly different frame of reference. Understanding time dilation requires us to rethink not just the mechanics of the universe, but our own place within it, and the intimate connection between motion energy and the passage of time. The great illusion of time begins with the simple question, what if the clock on your wall is not measuring your time at all? What if the hours you count and the seconds you chase are merely a reflection of a local experience of time confined to your position, speed, and gravitational environment? Philosophers have long debated the nature of time as a dimension, something that is not simply an arrow moving from past to future, but rather a fabric that can bend, fold, and stretch under certain conditions. Einstein transformed this philosophical speculation into concrete science, showing that time is intrinsically linked with space and velocity. This connection implies that time is not absolute and universal as Newton once suggested, but instead something that flows differently depending on how you move through the cosmos or the strength of gravity that surrounds you. To the human mind, this may sound counterintuitive because our daily experiences are grounded in clocks, watches, and calendars that tick uniformly, but the universe operates on rules that transcend ordinary perception. It is this tension between human intuition and cosmic reality that makes time dilation both fascinating and unsettling, and it invites us to explore questions that are as philosophical as they are scientific. Albert Einstein's theories of relativity provide the cornerstone for understanding time dilation, and they reveal a world where the passage of time is intimately tied to motion. The postulate of constant light speed forms the foundation of this theory and leads to remarkable consequences that defy our everyday expectations. Consider a train moving at near the speed of light with a light clock on board as a thought experiment. The light bounces between two mirrors on the train, and from the perspective of someone outside the train, the path of light is elongated, causing the moving clock to tick more slowly than a stationary observer's clock. This thought experiment vividly illustrates that time itself is not fixed, but can vary depending on speed. This is not merely a mathematical curiosity, but a physical reality that has been confirmed through experiments with atomic clocks, on high-speed jets, satellites, and even in particle accelerators. The twin paradox takes this a step further, showing that if one twin travels at relativistic speeds and then returns home, they will have aged less than the twin who remained on Earth. This bizarre result challenges our most fundamental assumptions about life, aging, and shared experience, and forces us to confront the possibility that each individual may inhabit their own unique timeline. Gravity introduces yet another layer of complexity to our perception of time. The warping of space-time by massive objects means that clocks tick at different rates depending on their position in a gravitational field. This effect is known as gravitational time dilation, and it is a central prediction of Einstein's general relativity. For example, satellites in orbit around Earth experience slightly less gravity than objects on the surface, so their onboard atomic clocks tick slightly faster. This difference may seem minuscule, but it is critical for the functioning of global positioning systems that billions of people rely on every day. Without accounting for this time dilation, GPS systems would quickly accumulate errors, rendering them useless. Extreme cases such as near black holes show a staggering demonstration of time's flexibility. Here, time slows down dramatically relative to distant observers, meaning that what might seem like minutes to someone near a black hole could be years to someone far away. This reveals a universe where the flow of time is not uniform, but dependent on circumstances and conditions that extend far beyond ordinary human experience. The implications are profound not only for technology, but for our understanding of reality itself. Even on Earth, subtle differences in velocity and gravitational potential can create minute variations in the passage of time between individuals. Although these differences are imperceptible in everyday life, they are scientifically measurable and real. This raises fascinating questions about personal experience. Could two people standing side by side technically live through a slightly different number of seconds in the same objective moment? As science and technology advance, it is conceivable that we may begin to experience these personal time dilations more directly, perhaps through high-speed travel or near-space habitats. The very notion that our individual timelines may not be identical challenges our assumptions about synchronization, universality, and the shared human experience. It forces us to consider that every conscious being may be inhabiting a uniquely warped slice of space-time, and that the clock that governs our lives is only partially universal. Shifting from physical time to psychological time adds another dimension to our understanding of dilation. The human brain does not perceive seconds, minutes, or hours as absolute units. Instead, our perception of time is influenced by attention, emotion, and engagement. A joyful moment with a loved one can seem to fly by, while waiting anxiously for news can stretch a few minutes into an eternity. This subjective experience of time mirrors the flexibility predicted by relativity and hints at a deep connection between consciousness and the flow of moments. The combination of physical and psychological time dilation suggests that reality is not experienced uniformly by any two individuals, even if they share the same environment. This dual perspective invites us to think deeply about what it means to live in the present and how our perception shapes the reality we inhabit. It encourages mindfulness, awareness, and a recognition that time is not just a measure of change, but a malleable medium through which we navigate life. Understanding time dilation has implications far beyond science fiction or theoretical physics. It challenges our notions of aging and mortality, as well as our understanding of personal and collective history. By recognizing that time is not absolute, we are forced to reconsider the meaning of past, present, and future in our lives. It opens the door to imagining travel through space-time, not just as a physical journey, but as a shift in perspective and consciousness. The recognition that individual experience of time may be unique encourages empathy and an appreciation of diverse perceptions of reality. It also inspires curiosity and wonder, reminding us that the universe is far more mysterious and dynamic than our senses might suggest. The more we explore time dilation, the more we uncover a cosmos